So my talk is modular pipelines for bootable containers. Let's start with who am I. Here are some of the places that you could reach out to me if you have any questions. And I'm an engineer on the machine config operator team at OpenShift. All right, so let's look at the agenda, what we got today. So we're going to begin with some of the basics of what are bootable containers. Then we're going to go about how do we scale their build workflow, and then what is the need for the model pipelines that I'm going to be talking about, and then how does it work, and what are the results that we got. All right, so let's begin with what are bootable containers. Bootable containers utilize the well-established OCI container ecosystem to deliver in-place transactional operating system updates. That means now you could encapsulate your entire operating system image into all your operating system deployment into just a container file. That means all your package data, unpackaged data, configuration files, if you want to enable FIPS mode, all those things is just one file. And obviously, since you now just have a file, you could commit it to your version control system. And using your favorite tool, build a podman, whatever you like, you could build it to a container image. And that's what we call the bootable container image, because it also, yes, has the Linux kernel inside it. And then you can use just the tooling, bootc switch, to just stage an operating system update. All right, so next the question comes, how do we scale this? Imagine that you have a microservice app, and it is running different microservices. So for example, Node 1 and Node 2 could be running a microservice, while Node 4 and Node 5, so each of these pair of nodes requires a certain set of RPM packages, custom scripts, which means that these set of nodes need to be in one state of the operating system, while the other pair of set of nodes need to be in other state of the operating system. This means now a user needs to be able to interact with only one API, and within that API, it needs to be able to specify all the different configurations in a container file, and then with the help of some build workflow, it should automatically build it to a container image, push it over to some registry, and then be able to deploy it into the specific set of nodes. And how do we do that? Our solution, Image Mode for OpenShift, which leverages the bootable containers on the OpenShift platform. And that singular API that I was talking about is the machine OS config. That means now you could specify your container file with all the configurations of the operating system that you want over there, as well as the image registry that you want to push it onto, and the set of nodes or the target pool that you want to deploy these set of container file to. And the build workflow includes first making the container image, building it, pushing it to some registry, and then deploying it to a pool. All right, so what's the problem? I'm telling you solutions. All right, but is this enough to deploy operating system updates? Let's see. It might be, but production readiness requires more and more and more, and more, and much, 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 much more. As all of you know, things break, and we need to fix them, which requires more production readiness. All right, so let's talk about some of the requirements we got here. Production readiness requires trust, and trust can only be established when you trust whether the images that you just built can be free from security vulnerabilities before you deploy them. And before you deploy them, you also, like a system administrator, would want to reliably test these container images, which is a really important part, because you don't want to be breaking these clusters overnight, and next morning you want to you'll have to again filter through the issues. It's a whole process that you don't want to go through. Also, make sure that the images that you push onto your registry is the same one that you pull from. This is a trust issue. First of all, once you build a container image, you want to use that same build pipeline to be able to, whenever you make small changes, it should not take that equal amount of time. Rather, it should cache those builds. And this is a really important part because a lot of the times you're not trying to build a container image from a completely different base image, but very few configuration files are changed. Moreover, to save some resources, you want to be able to lint the container files before putting it onto some build nodes. And then trust also requires being able to set rules around who can deploy these systems, who can push this to a container registry, or who can trigger this build workflow. So we come up with 3 design requirements for this workflow. First, that this build workflow should be modular. That means you should be able to arbitrarily add, remove different steps from your build workflow, and then once you are done with that, it should be reproducible. That means that same build pipeline can be called again to be able to produce that exact same container image. And then the third thing is we should have security. That means you should be able to define rules around role-based access control, rules around who gets to deploy and sort of trigger or maybe even re-trigger some of these build workflows, because resources are expensive and we want to control who is able to deploy them. All right, so here's my solution. Say hello to pipelines. We have a user, and what we did is modify the existing unified API that we have, which is called the machineOS config, and added these external steps called the pre-build actions and the post-build actions. Now, what these have is just references to existing tasks that you can create, and you just put the name over here. It will automatically add it to your build workflow. So for example, you can write your container files in the machineOS config and then set up another task to be able to lint it. And if it fails, this pipeline would not go through, and obviously you'd save resources. And after that, it would do the general steps of building it to an operating system image. And then this is the most important part. You should be able to test your operating system image before you deploy them. So you could define your own custom scripts. You can make them as a step to your post-build actions, be able to sign it, push it to your registry, verify that the image signature is the same, and then be able to deploy to pool. So before pipelines was a thing, the only steps were the non-blue, non-highlighted boxes over there. So this helps build trust in the system. So what's happening under the hood? How are you able to define these steps? So we leverage existing, well-known Tecton CI/CD pipelines. So OpenShift has its own version of Tecton, downstream version of Tecton called OpenShift pipelines. And being modular, as OpenShift pipelines is, it has already several different existing tasks. And one of the popularly well-known is the builder task, which is able to build these images as well as push them to a container registry. So what I did is just take those, just take them and then add it to my pipeline. And just to give a brief about how these work is that they have this concept of a pod. They have the concept of a step and a task. And a step can be abstracted to a container, while a task can be abstracted to a pod. So a pod can have several different containers. Moreover, you can have several different pods which run in in a sequential manner. OK. And each of these tasks after the build task, since we have already built the image, we just spawn a bootable container without running the Linux kernel inside. And obviously, all of these tasks can talk to each other using runtime arguments as well as any persistent volumes that you might have. All right, so let's look at a working demo for this. All right. So here I have already deployed a machineOS config, and let's have a look at it. So for example, over here in this machineOS config, we can see that we have defined a container file. And this container file, all it does is just downloads this package called Tailscale. And you can see I've specified what kind of image builder type I want. I want a pipeline image builder. And we have this important step called the custom test. And we can also say which pool do we want to deploy this to. So the machine config pool name infra. And now let's inspect what was the custom defined test that we wanted. So OK, and before that, let's just set up a watch timer on it so we can see all the different steps that it's going through. OK, let's let that happen for a while. All right. OK, now this was the custom task that I just introduced that happens post-build. So let's have a look at that. All right, you can see we have 2 tasks. One is the builder custom that I just cloned from the builder task. And this is the task that I just created and just linked the name. So all this task does is really simple. All it tests is the package the RPM package that we downloaded, does it exist? And this is just a step in this task. And if it doesn't, it should just fail over and entirely stop the pipeline from building. All right, now they also have this concept of OK, and this task is a part of this bigger pipeline, which is called the build and push pipeline. And this pipeline contains two tasks. The first task is the build task. And then the second task is the build a custom task. And the second task is the custom test task. And they have this concept of parameters that you can define. And you can see that you can say things like one task should run after the another. And you can do things like this. All right. Let's fast forward a little bit. All right, so we'll give it some time to build. All right, as you can see over here, the first task is running, which means like it's building the image and then pushing it to the intended registry. We'll let it build for a while. And over here, we can see if you look at the pods, there are two kinds of pods. There's the build pod and then the custom pods, which just means it's just running two different types of tasks. And as you can see above, the succeeded has turned to true. That means like our entire pipeline is a success. And wow, we have just built it. And this is the final pushback that we got. All right, so what do we take away from this? This means that pipelines allows your entire bootable containers workflow to be much more robust. You can now trust the system. You have custom tests that you can use. And all of this delivered by well-known OCI container ecosystem, as well as CI/CD pipelines that the developers already know, understand, and use. So if we use the same systems to build our operating systems instead of just application images, we can use the same tools and without any sort of learning curve, and they could as simply build the operating system images. OK, yep. And what's next? So this is not in production as of yet, but we are currently working on getting it in 420 as a dev preview and handing it off to users, customers. OK, thank you. We probably have 1 minute, but I wanna ask this question: what do you want to see from this new version of pipelines to build operating system images? If you have any other questions, also please.
So probably maybe my first question is the pipeline in its current form fixed, or is this something that a customer could potentially tune or tweak?
Yes, you could tweak it as you like it.
Is there anything beyond what we have with OpenShift pipelines, for example? Is there integrations with like Tecton chains so you can get like automatic attestation out of these, or any other kind of software supply chain features that are planned either directly in or something that customers can bring?
Right. Yeah. So currently, yeah, that's great. Thank you for the feedback. Like first, we want to like get the basic Tecton pipelines into preview, and then obviously we'll want to like know from customers, from users, what do they want, and we could obviously utilize what you mentioned, Tecton chains as well.
Can I use any of this without OpenShift, or is it purely built on OpenShift?
You want to use pipelines without OpenShift?
Yeah.
Tecton is an upstream project. You could utilize it wherever you want. This is a specific version of Tecton, which is OpenShift pipelines, and we use it to build image mode for OpenShift. So it's like fairly tied to OpenShift, but there's nothing about the upstream project that is tied to OpenShift. All right, if that's it, thank you so much for your attention.